And welcome to Sci-Fi. This is the first video in our machine learning problem solving series where we'll solve ML focused coding and interview questions while also understanding the real intuition behind the concepts. Instead of just memorizing solutions, the goal of this series is to think like machine learning engineer. And for the first problem, we are starting with one of the most important concepts in all of AI, which is gradient descent. Every ML and deep learning model, from linear regression to advanced systems like GPT, learns using this optimization algorithm. So, understanding gradient descent is the first step toward understanding how artificial intelligence actually learns from data. So, let's start. Now, the problem. Our goal is to minimize a simple function. For example, let's say fx is equal to x square. So what we have to do is we have to mathematically minimize the value of x. So as we see in graphs, this value occurs at 0. But instead of directly jumping to the answer, gradient descent approaches the minimum step by step. This is exactly how machine learning models optimize themselves during training. So to perform gradient descent, we need three important inputs, which is the number of iterations, the learning rate, and the initial starting value. So together these value control how the optimization process move towards the minimum. Next is the core intuition. The key idea behind gradient descent is simple. Follow the slope downhill. For this function, the derivative is f dash x is equal to 2x. So for the fx which was equal to x square, the derivative will be equal to 2x. The derivative tells us the slope at any point. So if the slope is positive, we move left. If the slope is negative, we move right. And the updated rule is then x new is equal to x old, which is old value of x, minus alpha, which is learning rate, times derivative of older x. So this is the main formula that would be using. And a very large learning rate can overshoot the minimum, while a very small learning rate makes learning extremely slow. So choosing the right learning rate is extremely important in ML and deep learning systems. So yeah, this is the core intuition behind follow the slope downhill, or while writing a proper uh, gradient descent. Now we are going to implement a getMinimizer function which will be used to minimize the function fx is equal to x square using gradient descent. So let's start. Now what we are given is we are given the iterations, the number of iterations that we are going to do, the learning rate, and the initial value of x. So as we have discussed before, our objective function is fx is equal to x squared, and then the derivative of if it is f dash x is equal to 2x, and the update rule that we have discussed before will be then x new is equal to x old minus learning rate times the derivative, and finally we have to round our final answer to 5 decimal places. So let's begin. So what we will take is, for ease of implementation, we will take a new variable x which will be equal to the initial value of x. So after that we will be running a loop which will run the iterations number of time. So for implementing that we will write for iter and iteration in range iterations, uh, and also we will be calculating derivative at each step. So derivative is equals to 2 times x. After that we will implement the update rule. So x equal to, this is the new x, equal to the x old minus the learning rate which is passed into the function parameter, and times derivative. And after that we will return round x down to the 5 decimal places. So yeah, let's hit the run button. So as you can see, the two initial cases have passed, and let's submit it. And yeah, this is how our first machine learning concept, which is gradient descent implementation, is complete. Now, let's see why gradient descent matters. So, this problem may look very simple to you, but this exact algorithm powers modern AI systems. In neural networks and deep learning, gradient descent updates millions or even billions of weights during training. In computer vision systems, gradients help modern models learn patterns from image pixels. And in large language models like GPT or Gemini, backpropagation computes gradients across multiple layers so the model can learn continuously and improve. A tiny optimization algorithm repeated billions of times powers modern AI. So this is the tiny optimization algorithm which is powering the modern AI systems. And this is exactly why gradient descent is one of the most important concepts in machine learning.